So let's say we wanted to find the standard deviation or the variance of a count x with binomial distribution. Well, we could set up a similar table as before for one trial with 0 successes or 1 success. And once again, we have p plus q equals 1 because those are the only two options we have, and q is equal to 1 minus p. So we just learned that the expected value is equal to p. So we can set up our variance for one event, and it would be 0 minus p squared times q plus 1 minus p, or the expected value, squared times p. And 0 minus p is negative p, and if we square that, we get p squared q plus 1 minus p squared p. Well, we know that 1 minus p is equal to q, so we can rewrite that as q squared p. From here, we can factor out a pq and get p plus q. And since we know p plus q is equal to 1, that simplifies to pq. So let's say once again that we had y equal the total of each event, individual event x, which is the same except we have the same trial repeated over and over again n times. In that case, the variance of y would equal x1 plus x2 plus so on until we get an n number of trials that is equivalent to the same as the variance of just x. And based on what we learned, we know that this is equal to the variance of x1 plus the variance of x2, etc., until we add the variance of xn. And we can substitute pq for each of these different variances. Well, the variances are the same each time, but we do that a total of n times because we have n number of trials. And as a result, we have n times pq, which we can rewrite because we know that q is equal to 1 minus p, and that's our variance. So if we wanted to find the standard deviation, we would take the square root of that, and then that would equal the square root of np 1 minus p.